In this video, we'll be talking about the concept of the limit. Now, before we delve into what the limit actually entails, we're going to break down the various parts that make it up so that it's easier to understand moving on. Now, the limit is first built out of the limit itself, then the argument, which is going to be the function that the limit is operating on, and then finally the input value c of the limit. Now, essentially, a limit is an operation on a function, similar to squaring or square rooting, in the sense that it performs some kind of operation. So, I think that a very good representation of the limit can be seen through a magnifying glass. But, not just any ordinary magnifying glass, a magnifying glass which zooms in and examines a function to infinity. Now, I'm going to use this function as an example. Let's say we wanted to take the limit as x approaches 2.5 of this function. Using the magnifying glass model, we will zoom in on this point, x equals 2.5, until we can make f of x arbitrarily close to some value. Now, essentially what we're doing here is zooming in until we can get close enough to the value of x equals 2.5 to estimate around what this function approaches from left and right. So we can see here that on the right, the function is approaching 0.75, and from the left, the function is approaching 0.75, almost looking like a horizontal line when you zoom in close enough. Therefore, the limit as x approaches 2.5 of this function is 0.75. However, it's important to note that just because the function exists at x equals 2.5 and has 2.5, 0.75 lying on its curve, that doesn't mean that the limit automatically equals that value. Now we can model how this is not simply a measure of equality through a different example at this hole at x equals 1. Now, a hole signifies that the function does not exist and has no value at this point. However, if we look as we get closer and closer to this value, the y value is getting closer and closer to 3. Now, you can see here that exactly at 1, the function is undefined. But from both directions, as we approach this, it's getting infinitely closer to 3. And although it doesn't quite meet the value of 3, it's still approaching this value, and therefore the limit as x approaches 1 equals 3. Now, occasionally, you may see a limit written like this, or perhaps even like this. Now, these are simply modifications to the limit notation which specify what direction you're taking the limit from. These are not exponents. They're simply markers of what direction to take the limit from. So, a plus sign indicates that you are taking a right-hand limit, and a minus sign indicates that you're taking a left-hand limit. And although you may not know what these mean for now, we're going to look at a graphical model to see exactly what it means to take a right-handed or left-handed limit. So, given this function, we're going to take the limit as x approaches 1 from the right of f of x, and the limit as x approaches 1 from the left of f of x. So, essentially, taking a right-handed limit indicated by a plus sign means that you're examining what the limit approaches only going from the rightward positive direction to the leftward negative direction. Now, this means that we're going to start from the right, moving this way, ignoring everything over here on the left, and see at this value of x equals 1 what the function approaches. So we can see here, only going from the right, that this function is approaching the value of 2. Now, similarly, if we're trying to take the left-handed limit, we're going to see what the function approaches from left to right. So we're going to ignore everything over here. Now, you can see here if we press the magnifying glass to the function at this point and zoomed in forever, that this function would approach the value of y equals 1. Again, both of these examples show that the graph has a hole at the respective point it is examining. So it's again important to know that just because the function does not exist doesn't mean the limit does not exist. However, it's also important to note here that differences between the right-handed and left-handed limit, considering the right-handed limit equals 2, the left-handed limit equals 1, lead to some problems when it comes to the limit as x approaches 1 of f of x, regardless of direction. The first property of a limit which is important to know is that if the limit as x approaches 1 from the right of f of x does not equal the limit as x approaches 1 from the left of f of x, then the limit as x approaches 1 of f of x does not exist. So therefore we can say that overall the limit as x approaches 1 of f of x does not exist, which you can see here if we look at this graph and we press a magnifying glass. It's approaching different values from each direction, meaning that this function does not approach overall one value as we press a magnifying glass, which is why overall the limit does not exist. Now, I have another video covering infinite limits, but just as a quick introduction, we're going to examine what happens when you take a limit as x approaches infinity. Now, taking a limit as x approaches infinity is actually going to require you to consider the end behavior of the graph. However, this is going to become a lot more clear what this end behavior even means by considering a table. Essentially, a limit as x approaches infinity is different than the other limits we've discussed, as rather than having an input value that is a number, such as 1 or 2, we have infinity. And it's important to understand that infinity is a concept and not a number. It's simply a concept of a quantity that goes on forever without bound. This is extremely important to understand learning the principles of calculus. So, if we're trying to find the limit as x approaches infinity, we need to figure out what value this function approaches as it increases without bound and approaches infinity. Again, never actually meeting infinity. So using this table, we can see that as the values of x increase, the values of y are approaching 2. And although they never quite will meet 2, as this function actually has what is called a horizontal asymptote along the line y equals 2, which can never be crossed, this limit will still equal 2, considering that as the function approaches infinity and gets infinitely large, its end position, we can examine through the magnifying glass model, is actually going to approach 2. Again, it's important to note that this function never actually equals 2, but the limit as x approaches infinity is still 2, signifying that just because the limit equals a value doesn't mean the function will equal a value. So therefore, using this method, you can use a table to determine a limit. Now, using this model, we're going to talk about some cases where a limit may not exist. So, let's say we wanted to take the limit as x approaches 1 from the left of f of x. Now, this means that we're going to take the limit from the left negative direction towards the rightward positive direction, discluding everything on the right side over here. So, if we use the magnifying glass method and look at what this function approaches at x equals 1, we can see that it's actually increasing without bound and approaching infinity. Now, because this function isn't approaching any set value, this means that the limit does not exist. However, depending on how your teacher wants you to express this answer, you may also say that this limit approaches infinity. Now, it does not equal infinity, because infinity is not a value and cannot be placed in expressions of equality. However, still, because this function increases without bound, it is approaching infinity and going on forever. Now, let's say we want to take the limit as x approaches 1 from the right of f of x. Again, only considering the right side of the function, disregarding everything on the left side of x equals 1. Now, using the magnifying glass model, we again see that this function is increasing without bound. And so, because it's not approaching any value like 1 or 2, it again does not exist. Now, let's say this function was decreasing without bound, approaching the downward direction. Then this limit would still not exist, but it would approach negative infinity instead, which is the concept for something that is decreasing without bound. It's also interesting that if we took the limit as x approaches 1 of f of x, this would approach infinity. Even though both sides of the limit are non-existent, because they both approach infinity, again, they don't equal infinity, because they both approach the same concept, that means the overall limit approaches infinity. Now, another reason that a limit may not exist is if it has some kind of oscillatory motion. So let's say we wanted to take the limit as x approaches infinity of f of x. We're going to have to consider the end behavior of this graph. And as we can see here, putting a magnifying glass to this end behavior, this function is moving in a kind of wave motion, which is called an oscillation, which is a term to describe this kind of wave motion that goes on forever and never settles upon a certain value. So, because the function is oscillating as x approaches infinity, that means it's never going to settle on one certain value, always moving from here to here to here to here and back for an infinite loop. So therefore, the limit as x approaches infinity of f of x for an oscillatory motion is going to be non-existent. And you're typically going to see this kind of behavior for graphs like sine of x or cosine of x. So as a quick summary, there are 3 reasons for a limit to not exist. The first is if the left-hand limit does not equal the right-hand limit, as we could see through this example where the limit from the left equals 1 and the limit from the right equals 2. The second way is if a function increases or decreases without bound, approaching either infinity or negative infinity. And finally, if the function oscillates, such as sine of x or cosine of x. So this was a quick introduction to limits and the concept of infinity. And if you want to learn more about how to solve limits using algebraic methods, check out my other video on that. However, other than that, thanks for watching. Make sure to like and subscribe, comment any other concepts you may want me to cover down below,